Miss you guys. Hope these examples help you as you get through today's lesson. All right, today is March the 31st. Your proverb for the day is from chapter 8, verses 27 and 28, and we'll read it as we get around the other side of the board. We're on page 121 of our text. We're in section 1.6. The juniors and Aaron did 1.5 the week before spring break. Today we're looking at other types of equations or equations higher degree than we've been normally working with, such as 3, 4, 6, or 8. These polynomial equations, again, are going to have a higher degree. And we'll just get started. I chose some problem numbers from the homework section. This is, again, page 128. This is problem number 6, and it reads 36x cubed minus 100x squared equals 0. So if it equals 0, we are looking for a solution for this equation. It appears there are going to be 3. Some of them may be repeated. Time will tell. So I would use the tool always, would be greatest common factor. So always look for greatest common factor first. The greatest common factor between these two terms is definitely an x, and I believe they're both divisible by 4. So let's see what remains when we divide by 4x. 4 goes into 36 9 times. X goes into x cubed, x squared times. Or 4 times 9 is 36. X times x squared is x cubed. Then 4 goes into 100 25 times, and x goes into x 1 time. So go back and double check. 4 times 25 is 100, and then times x with a minus sign. Now, this is factored, it's just not fully factored. So we've still got our greatest common factor out front. This appears to me to be a difference of squares. So 3 times 3 is 9, x times x is x squared, and square root of 25 is 5. So as we take each one of these factors and set them equal to 0, when we solve for x, that will give us the 0. So when we divide both sides by 4, one of our solutions is 0. The other one, when we take the 5 to the right side, it becomes positive. When we divide by 3, both sides, we get x equals 5/3. So I think just the opposite is going to happen for this next factor. We have 3x plus 5 equals 0. 3x equals negative 5. X equals a negative 5/3. So here are our 3 solutions. They are all unique. That is not going to happen with every problem that we deal with. I'm going to move my camera over. This problem is similar to number 7 in the text. It reads x to the 4th power minus 64. So there are going to be 4 solutions for this problem. 4 values that we can plug in for x. Then when we do, that'll be 64. We subtract 64, we get 0. You're not asked to check, but you'll be able to check your answers in the back of the text because I'm going to assign you the odd ones. So this one, if you think about difference of squares, this factors into x plus 8 minus 8. So for us, it's going to be just a little bit different. Since we're in x to the 4th power, these exponents are going to double. Then you take each factor and set it equal to 0. So we get x squared equals negative 8. So x is going to be plus or minus the square root of a negative 8. When we take square root of negative, so we get imaginary numbers, so it's x equals plus or minus, then it's the square root of 8 times I, because we have this negative and we want to take the negative out from under the radical. Remember, you're going to do a factor tree for 8. 2, 4, 2, 2. So we got a pair of 2's. You get x equals plus or minus. From the pair, 1 gets to come out. You're left with square root of 2 and then I. So the first 2 answers out of the 4 are plus or minus 2 square root of 2 I. I don't know if you can see that or not. Plus or minus 2 square root of 2 I. And then let's look and see what happens with the other 2. We get x squared minus 8 equals 0. X squared equals a positive 8. X equals plus or minus the square root of a positive 8. So this time we don't have the imaginary to deal with. But we do end up with radicals simplified. Plus or minus 2 times the square root of 2. So we have 2 imaginary zeros and 2 real zeros. If you were interested in kind of what it looks like, square root of 2 is like 1.41. So we're down between 3 and 4. These things are going to have a couple of real roots and then a couple of imaginary roots. So that should be about how it graphs out. All right, I'm going to stop the video.